This is 8.6, scientific notation. Scientific notation is a number represented as the product of a factor and a power of 10. The factor must be greater than or equal to 1 and less than 10. So it can be 1, but it must be less than 10. An example of that is 4 times 10 to the third. So to write numbers in scientific notation, we're going to move the decimal point so it is to the right of the leading non-zero digit, so the first real number that we have. Then the number of places you move the decimal point indicates the exponent of the power of 10. So similar to how we did with estimating quantities in 8.5, the only difference here is that we are not rounding the numbers first. So we're going to write them in scientific notation. 50,000, this decimal is at the end, move it to the left 4 times to get 5 times 10 to the fourth. 683, we'll move the decimal twice to the left, so I get 6.83 times 10 squared. So I keep all the digits that are in here. I can only get rid of them if they are all zeros at the end. This one is a very small number, so I'll move it just to the right after this leading non-zero number. So this will be 3.87 times 10 to the negative 3. Remember, when you move the decimal to the right, you have a negative exponent. On this number, I'm going to move it right after the 4, and that makes 7 times, so that's 4.1036 times 10 to the negative 7th. Here, since they're all zeros after, I'm going to get rid of them, but the decimal is in the middle, so I only move it once to the left. So it's 5 times 10 to the first power, which is 5 times 10, which is 50. This one, 50.01, I have to keep all of these because of that number at the end. I still move it once to the left because I need the decimal right after the first non-zero number. So that's 5.001 times 10 to the first power. So that's writing in scientific notation. Now we're going to go from scientific notation to standard form. So the exponent shows how many places to move the decimal point. If it is a negative, so we ended with a negative, to take it out of scientific notation, we're going to move the decimal point to the left. So we are undoing what we did up here. If we have a positive exponent, we are going to move the decimal to the right. So let's write these in standard form. 3.62 times 10 to the negative fourth. So it's a negative, move it to the left 4 times, so that is 0.000362. Here I have 6 times 10 to the 7th, positive number, move the decimal to the right 7 times, and fill in all those little spaces with zeros. So that is 60 million. Here I have 5.3 times 10 to the 6th power, so move it to the right 6 times to get 5,300,000. And this one is 6 times 10 to the negative 7th, so I'm going to move it to the left 7 times. So we can see this very small number, and this one is a very large number. So it does matter if they are positive or negative, because we know that they will represent different numbers.